All right, here's another example of reading a graph. Here we're using baseball gloves as what we're making. So we have a baseball glove factory that's making baseball gloves. Here we're going up by 200, 400, 600, 800. So each notch of baseball gloves goes up by batches of 200, all right? And here on the dependent axis, it's a little bit different than before. Here it's going up by $4,000. So each notch here is 4,000. So it goes from 4,000, 8,000, 12,000, 16,000, 20,000, and so on. So on the dependent axis is the total amount of dollars that it costs to be able to produce its product, which is, in this case, baseball gloves. Okay, so let's look at this. What is our fixed cost, or otherwise known as our overhead cost, or our y-intercept? You can think of the overhead cost, an easy way to remember that is think of like overhead lights. Like, it's just a way to remember. Think of overhead costs as like all of the things that go into just keeping a factory afloat, even if they don't make anything. So like the lights that are above, the overhead lighting, the heat that you need to fill the building during a winter day, or the air conditioning during summer days, or the employees' salaries. All these things go into making a factory get up and running before they actually even produce any of its product, okay? So all these things are called its fixed cost, overhead cost, y-intercept. In this case, what is it? The graph goes through right here at 12,000. So that means our B in this case is $12,000, all right? That's our fixed cost. Now we need to figure out what our slope is, all right? So let's see, it goes up by $4,000. Each of these notches, remember, please take into account the scale of each of these notches. These notches now, in this case, in this particular example, each notch is $4,000, okay? So if I go from here to here, that's 4,000. Just one notch is 4,000. Okay, so if I go up 4,000, that's a Y change of 4,000 from 12,000 to 16,000. If I start at 12,000 and I go up to 16,000, I increased $4,000. So for that change in $4,000, how many hats did that get me? Well, it got me 200 hats. Do you see how 200 lines up here? So it got me 200 hats right here, okay? So the slope is 4,000 over 200. Let's reduce that. So we can cross out as 0 on top, 0 on bottom, 0 on top, 0 on bottom. So we're left with 40 over 2. 40 divided by 2 is 20. So our slope here is 20. That's $20. That means it's $20 per glove, per baseball glove, okay? That's our slope, which means it's the price that the factory has to pay per glove. And what goes into the actual glove itself? Leather, you could say. So I would say leather and stitching, all of those pieces that go into the actual glove itself are part of this, the price of the glove, the variable cost. We call what goes into the item itself is the variable cost. Why is it variable? Because the more we make, the more material we need. The amount of material we need varies with how many units we want to sell or we want to create, okay? So while the fixed cost, the light stays on no matter if we make 1,000 gloves or 1,000,000 gloves. We still need the same amount of overhead lighting. But what does change if we go from 1,000 gloves to 1,000,000 gloves is all that leather that we need and all that stitches that we need to buy and all the thread and the sewing that needs to go into each of those gloves. That varies if you need to produce more gloves. So that's why what goes into the actual glove itself is called the variable cost. That variable cost is the same thing as the slope, all right? And so our slope, we found out, is $20. So we can put it over here, our y equals mx plus b form, our slope-intercept form. Our slope is 20, so that's 20x. So it's y equals 20x plus 12,000. That is the equation of the line that represents this relationship that is on the graph, all right?